Welcome to The Explainer. Today we're going to tackle a super important topic in Docker, making sure your data actually sticks around. Because let's be honest, there's a nightmare scenario every new user faces. You run a container, you remove it, and poof, all the data inside is just gone. We're talking database records, user files, logs, completely vanished. But don't worry, we're going to fix that right now.
So let's walk through a classic scenario, one that gets pretty much everyone at the beginning. You're working away, you decide to clean up your environment, and then that sinking feeling hits, wait a minute, where's my stuff? Okay, so first things first. We spin up a totally standard Ubuntu container, give it the name test, and pop open a command prompt. Inside, we just run a simple echo command to create a file called data.txt with some, important data in it. So far, so good, right? Everything seems totally normal. Now, once we're done, we do what any good developer does. We clean up our workspace. We exit the container and run docker rm test to get rid of it. Keeps the system nice and tidy. And here comes the moment of panic. We start a brand new Ubuntu container thinking we'll just pick up where we left off. We go looking for our data.txt file and nothing. The system just tells us no such file. It's literally vanished into thin air. This right here, this is the exact problem we're here to solve. So what in the world just happened? Now, the first thing to know is you didn't do anything wrong. This isn't a bug. It's actually a core feature of how Docker works. It's called the ephemeral container problem. And once you get your head around it, you'll be in control.
Okay, so here's the deal. Every single container has what's called an ephemeral or temporary file system. Think of it like a sticky note you put on a book. The book itself, the base image, is read-only. But you can scribble whatever you want on that sticky note. Any files you create, any software you install, it all goes on that temporary layer. But the second you remove the container, you're not just throwing away the container, you're throwing away that sticky note and everything on it. It's designed to be disposable.
And this is where it gets really scary in the real world. We're not just talking about a little text file. For a real app, this means your database loses every single record. Your critical logs disappear. Any files your users uploaded are gone. All of it, lost, every time a container gets updated or replaced. And yeah, that's just not going to work for any serious application.
But okay, deep breaths. Docker isn't trying to trick you into losing your data. It actually gives us 3 really powerful and distinct ways to solve this problem. These let you keep your data safe and sound, completely outside of that temporary container lifecycle.
So this chart lays it all out for us perfectly. First, we've got volumes. These are managed completely by Docker, and they are the #1 choice for production data. Next up, bind mounts. This is where you connect a folder from your own computer directly into the container. Absolutely perfect for development. And finally, you got the special one, TMPFS mounts. This is a Linux-only trick where data gets stored in your computer's memory, or RAM. It's blazing fast, but the catch is the data disappears the instant the container stops. It's great for sensitive info you never want to write to disk.
All right, let's start with the big one, the most important solution you'll use, volumes. This is Docker's official, recommended way to handle your data, especially in production where you just can't afford to lose anything. The real beauty of a volume is that it has a life of its own, totally independent of any container. So first, you create a volume, we'll call it My Data. Then you start a container, say a MySQL database, and you attach that volume to the exact folder where MySQL keeps its data. Now here's the magic trick. You can stop and completely delete that database container. But your My Data volume, it's perfectly safe, just hanging out, managed by Docker. Then you can fire up a brand new container, reattach that same volume, and boom, all your data is right back where you left it.
And what makes volumes so powerful is that Docker treats them like VIPs. They're what we call first-class citizens. This means you get a whole dedicated set of commands just for managing them. You can create them, list them all out, inspect one to see all the nerdy details, and of course, delete it when you're really done with it. And that prune command, that's a lifesaver for cleaning up all of the old, unused volumes that are just taking up space.
Okay, so volumes are our go-to for production data. But what about when we're actually writing the code? For that, let's turn to our other essential tool, bind mounts. And if you're a developer, you're going to love this. So, a bind mount works differently. Instead of letting Docker manage everything, you're the one in charge. You're basically telling Docker, hey, see this project folder right here on my computer? I want you to make it appear inside the container at this specific path. And the result is an amazing, instant feedback loop. You can be editing your code in your favorite editor, hit save, and the app running inside the container sees that change immediately. No more rebuilding the entire image every time you fix a typo. It's a massive game changer for productivity.
And this right here, this is the big aha moment. It really boils down to this. With volumes, Docker is in control. They're portable, they're easy to back up, and they're the obvious choice for application data like databases. With bind mounts, you are in control. They rely on a specific folder path on your computer, so they're not great for production, but they are absolutely perfect for that live coding development workflow. It's all about using the right tool for the job.
All right, let's lock in the key takeaways. Number 1, and this is the most important, always treat your containers like they're temporary. Number 2, for any data that needs to survive, like your database, you're going to use a Docker volume. Number 3, for that super fast coding feedback loop, a bind mount is your best friend. You can use the simple V flag or the more detailed -mount flag to set them up. And here's a little pro tip for you. If a container only needs to read some config files, you can add RO to the end of your mount to make it read-only. It's a great little security boost.
And really, that says it all. Once you understand this split, volumes for production data, bind mounts for development code, you've seriously leveled up your Docker game. You've officially gone from that horrible, panicky feeling of losing your work to being in complete control of your data's lifecycle.
Okay, now it's your turn. The best way to make this stuff stick is to actually do it. So here's a little challenge. Try running a Redis container. Use Docker volume create to make a new volume, and then use the -v flag to attach it. Then try stopping and removing the container, bring up a new one attached to that same volume, and see if your data is still there. Go on, give it a shot. You've got this.